Today, we're going to be talking about front-end application deployment patterns. Maybe. Still maybe. There we go. So I'm a product manager, and product managers like to create customer personas. And these are the fictional characters we use to represent different people or attributes of people that might be using a product or project. Now, Kubernetes is infrastructure software created by infrastructure engineers for infrastructure engineers. That's how the project started. And looking across the Kubernetes ecosystem, this is code examples, documentation. So much effort is focused on the platform engineers, our backend architects, and like executive leadership. Dozens of consulting engagements. I found that web developers are often left to fend for themselves and figure out how to best deploy their applications to Kubernetes. And Kubernetes is a powerful deployment platform. It allows complex workflows for shipping software. It's one of the reasons that I love it. But safely managing these complex deployment patterns for front-end applications can be fraught with challenges. So if you're working with things like HTML, CSS, and JavaScript, if you have streaming APIs to your backend applications, that can get complex very quickly. And one of the common issues that I've seen with web developers when they're trying to run their applications is they'll start to do a deployment's running, and all of a sudden they start seeing a whole bunch of 404 errors. Or they get user reports saying that they're having a bad experience. They went to go click on a button and the button stopped working. So my goal today is that when you leave this presentation, I'm hoping that you're equipped with a variety of strategies to deploy your front-end applications to Kubernetes. So first, let's look at some common Kubernetes deployment patterns. These are things that are built in or capable all through the Kubernetes API. So when you're looking to deploy, the sort of 4 common ways that I see people deploy software. Number 1, editing files in production. This is cloud native. We're not doing that. That's not allowed. You do not have access to the file system of your pods once they're running. The other strategies are rolling update. So rolling update allows you to shift from one version to another in a gradual manner. And this is great for minimizing the amount of compute resources, so CPU and memory, that you need to have running to do your update. You're sort of doing an in-place upgrade one at a time. But it does require that your application versions and APIs are backwards compatible. So version 2 needs to look like version 1. And that means you have to do extra work for your applications. Blue-green, or sometimes known as red-black, allows you to do an instantaneous switch from one version to another. This minimizes those version compatibility issues, but it does require that you have double your compute resources to have 2 versions of your software running at any given time. So if you have a very, very large scale application, you're going to require a whole lot of extra compute to have 2 versions running at the same time that you can switch between. For more advanced users, once you sort of master those first 2, you may also look, and you may have heard of Canary-based deployments. And Canaries allow you to evaluate a new version of your application for a small subset of your end users. So rather than doing a rolling deployment or blue-green, you pick 5% or 1% of your users and you send them to the new version. When that new version, if you're looking at your metrics, you're looking at Google Analytics, the data looks good, then you can complete your rollout. Now let's take a look at what these look like in Kubernetes. So here's an example rolling update. I have a cloud load balancer that is pointing to a Kubernetes service. The server is using a label selector, app equals my app. So any pods that have that label, app equals my app, will receive traffic through this service. I have one large deployment called my app, and it's currently managing a replica set. A replica set has 3 pods. You'll notice in red, there's a pod template hash. So replica sets and deployments, as they manage the different versions, apply a hash to each replica set in those pods. The blue part, app equals my app, tells me that this service will send traffic to all of those pods. So when it comes time to do a deployment, I can edit my deployment YAML, so I can change my container image or change some other property of that pod template in that deployment. Kubernetes will start a new replica set. You'll notice that it still has app equals my app, but the pod hash is different. So I've got different versions of my deployment template. Kubernetes then scales up this new replica set. Once this new pod is up and running, it takes down one from the old one. And it brings up a new one, brings down an old one. This is our rolling deployment. Eventually, Kubernetes will remove that old replica set. Great. And there's a couple of different ways you can change the behavior. So that's the default Kubernetes rolling deployment that I just showed you. You have some controls that you can modify. So if you're using kubecontrol, you can use the kubecontrol explain command to give you information about the deployment spec strategy rolling update. You also can go find the nice, pretty Kubernetes docs. There's two knobs that you can tune. The first is max surge. So max surge changes it sets the maximum number of pods that can be scheduled when you are scaling up or scaling a new version. So max surge, if you have max surge 3 in our example before, instead of bringing up one at a time of the new versions, it'll bring up all 3 of my new replica set. As those pods become ready, then my old ones will get curated. This can be a number or percentage. I often set it to 100% if my applications are not too large. Like, go ahead and burst, I've got capacity. But if you have a large deployment, you'll want to set it to a more reasonable number. The other knob you can tune is max unavailable. So this changes the maximum number of pods that can be unavailable during the update. Again, a number or percentage. I often set this to something around 70% because I usually have overhead spare capacity when I have my number of pods running based on the amount of traffic that I expect to receive. But this again can be tuned based on your availability and performance requirements. Okay, so that's our rolling deployment. How does this work for a web-based app where you have multiple assets? So let's go back somewhere in the middle of that deployment process and see what the end user experience might be. Okay, we're in the middle. We have 2 pods running the new version, 2 pods running the old version. Here's our user. They're going to make a request to index.html. So the browser connects to Cloud Load Balancer, forwards the traffic to the service, and the service in a round-robin fashion picks a pod to send traffic to. So it's going to get, this end user is going to get the content from pod 1, index.html from pod 1. Great. Here's my index.html. I'm referencing 2 external files, main.css and main.javascript. The browser now needs to, it reads through the DOM, it recognizes it needs to download these external assets, it goes back to the Cloud Load Balancer, so it gets the main.css, version 1, that's good, comes back. Now we're going to request main.js. Version 2. Does my version 2 of main.js correspond with the HTML contents I have version 1, or my CSS? Maybe, maybe not. And this turns out to be a pretty big deal. And so this is the common scenario that I see over and over again where people are first deploying applications, web-based applications. They do the deployment, and if it's just them testing, they see that problem sometimes, but not always. As you scale out, if you have lots and lots and lots of users requesting, there's going to be some percentage of users that are going to get broken page load. It may not be all of them, but it may be enough to cause problems. Let's look at the next strategy, blue-green. So here, I have, again, my Cloud Load Balancer. I have my service. My service now has 2 label selectors. First is my app, and also version blue. So any pods that have both of those sets of labels will then match. So in this case, on my left-hand side, I have my deployment blue. My app, version blue. So all traffic through the service is going to go flow to those pods. My green pods have version green. So even though they match app equals my app, the version green does not. So they're not going to receive traffic. So if I want to do a blue-green deployment, all I'm going to be doing is changing my service label selectors. Change the version to green. Now all traffic is instantaneously switched over to my green-based deployment. Now inside of each blue and green deployments, you're probably still doing a Kubernetes rolling deployment. You don't have to, but that's the default. You can pick and choose how you want to roll out those applications, but your end users are just experiencing the blue-green switch. So from a web development perspective, this is great. All requests either get version 1 or version 2. Maybe there's a very small percentage of people that just happen to be in the middle of that switch, but because it's such an instantaneous switch, it's going to be much, much smaller than our rolling deployment, which might take minutes or hours, depending on how long your web apps take to boot up. But it is important to recognize that you will need double the compute resources. So if your application uses lots of CPU and lots of memory, this deployment strategy is going to require additional capacity to make sure that it can handle all these applications that are running. Let's look at the last one, the most advanced. And my recommendation is don't get started with Canary. Start with one or the other. Get comfortable with Kubernetes. Get comfortable with understanding how your applications are going to behave in a cloud-native environment like Kubernetes. Once you've mastered that, once you have monitoring tools, then you can start to look at more advanced patterns. So let's look at Canary-based deployment. Again, I've got my deployment stable, and you'll notice that my service references just app my app. When I want to start my Canary-based deployment, I'm going to have another longer-lived deployment. The same app equals my app label applied, so traffic from our service is going to go to both sets of deployment pods, but you'll notice that the versions are slightly different. So what this means is that 1/4 of my requests are going to go to version 2, and the other 3/4 go to version 1. So this is good if I'm wanting to do an experiment. I want to try out a new version. Maybe I've made changes to my application to add caching of my CSS and JavaScript contents inside my process instead of having to go to disk every time. I can test this by rolling out version 2, see the performance. Hopefully I'm seeing less CPU or maybe less disk I/O, or the latency requests are going down. And if I'm happy with it, if version 2 looks good, then I can trigger a rolling deployment of my stable deployment. So to do that, version 2, version 2, version 2. Now, the ratio here between the amount of traffic that goes to version 1 and version 2 is tied to the number of pods that I have running in each category. So if I want to have 10:1, I have to have 9 pods with 9 pods running of the new version and 1 of the old. So I want that type of ratio. And that's what this looks like. So if I want to have more version 2 of my stable and less, this becomes complex to manage. Like if I want to shift my ratios dynamically, it's not really a very friendly way to do this. If we go back to our web development world, this isn't good either. On a consistent basis, all of my users are going to be getting some mix of version 1, version 2. And you can even stagger. You can have multiple Canary versions. You can have stable, beta, and alpha. Now your users are going to see all sorts of craziness when it comes to time to page loads. So a quick deployment recap. Rolling updates, they require fewer computing resources. It's the default for a Kubernetes deployment object, but it can lead to broken page loads and missing static assets. Blue-green, near instantaneous switch, which is good. That's what we want from a web development perspective, but it does require a lot more compute resources. Finally, Canary, it's great for validating changes, but again, from a web development perspective, broken page loads, and we don't have a whole lot of flexibility on how we shift traffic between those two. All right, so let's work through some possible workarounds, how to get around these things. Well, number one, you can just ignore your problems. If your application is not used very often, if it's an internal app or it's something that people use on a periodic basis, you can just roll it out and some users have some broken page loads. Maybe that's okay. Look at your business requirements and see if this is something you need more. You can also have scheduled maintenance windows. It's not very cloud native of us, but you can do it. My local bank does this every Sunday night from 6 till 10. I can't make any changes to my financial, can't see how much money I have. But this is definitely an option. So look at your business requirements, look to see how much availability you need to have, how many deployments do you want to have. If you, as a web developer, like as we're moving towards this cloud native world, we want to be able to deploy continuously. We want to make sure that we can roll out new versions as quickly as possible. That's both to increase our product development speed, but also allows us to fix things quicker. If we roll something out that's wrong, we can fix it quickly. We also can leverage content delivery networks. So a CDN, for those of you who don't know, there's companies like Akame or all the cloud providers have compute and network at the edge near regional network connections. And they basically can store your static assets for you. So if we go back to my index.html, I can reference my CSS and JavaScript using, in this case, I'm using S3 as a bucket store to hold this. What's nice about this is that my user is still going to make a request for index.html. Their browser is going to download this and then go to S3 to get the additional static contents. You also note that I'm versioning. So my index.html references the appropriate versions of my static assets. If I want to roll out a new version of my software, I'm going to bump to version 2, version 3, version 4. Probably more likely, a better way of doing that instead of having static versions, have it tied to a Git SHA. So when you do a check-in of your source code, you're going to have a unique ID that represents that particular commit. As part of your build process, take that and inject that into your path. So your browser will always be, the browsers will be making requests to the appropriate version. Another thing we can do with Kubernetes services is we can leverage session affinity, or sticky sessions. In the service object, you can add the session affinity flag. There's two options, none, which means just round robin, send it to the next one, or client IP. But what client IP is that? My end user has this 128.2. My cloud load balancer has got a 10.1.1.3. What does client IP in this case mean? It actually means that the cloud load balancer, not my end user. And as it turns out, not all cloud load balancers support passing through that client IP. So there are ways to do that. Google, for example, Google Cloud Load Balancer does work with session affinity to pass through their layer 4 load balancers. ELB does not. So it's just something to be aware of. We also can leverage something like HTTP 2. So HTTP 1.1 is usually the current standard. HTTP 2 has been out for a while, for many years, and all the major browsers support this. What's nice about this is the browser creates a single multiplexed connection. So it opens one TCP connection through that cloud load balancer, through the service to a pod, and all additional requests for CSS, HTML, JavaScript images, everything flows through that pipe, which means we don't have to worry about the sticky session problem anymore. It also has some additional benefits. It's a binary protocol, so there's less overhead from HTTP 1. And because everything goes through the same pipe, there's reduced round trip time of like having to make multiple and open multiple different connections. So this is good, especially for mobile apps or mobile websites. But one thing to keep in mind is every time you want to deploy a new application, you're going to have to create a new service. And that service is going to have a cloud load balancer. And it turns out cloud load balancers are expensive, especially if you have lots and lots and lots of applications. Thankfully, there's a way to avoid the sprawl of load balancer, and that's Kubernetes Ingress. Ingress provides us a way to route requests to services based on the requested host, so www.heptio.com, or path, heptio.com, excuse me, heptio.com/blog. This is layer 7 load balancing. So Kubernetes services operate at layer 4. Layer 7 or HTTPS load balancing is what Ingress provides. So what does this look like? So inside our Kubernetes cluster, we deploy this Ingress controller. And there's two pieces. One is the thing that's doing the load balancing. So this might be Nginx or HA proxy. The other is the controller. What the controller is doing is talking to the Kubernetes API server, and it's monitoring all of your services. It's monitoring all of your pods and endpoints, and it's also monitoring the Ingress objects that describe this configuration. So we now can route traffic to many services, all through a single cloud load balancer. And there's a lot of Ingress controllers, which is great. So Nginx, by far, I think is the most popular. Heptio Contour is one that we've built. And there's also Trafic. A lot of the cloud providers have their own. And there's also ones for on-prem installation as well. I want to talk quickly about Heptio Contour. So we built this in partnership with Yahoo Japan Corporation subsidiary Octapio. So they're the group that's responsible for the cloud natification of Yahoo Japan. Contour uses Envoy as the data plane. So Envoy is the load balancing service proxy that was built by Lyft. So Lyft, the ride-hailing app, all of their traffic runs through Envoy. And the Heptio Contour dynamically updates Envoy without dropping any connections, which can be a problem with some controllers. And we've also done extensive performance testing to millions of concurrent connections. And actually, there's two other talks this week on Contour and Gimbal, which is its sister project. Yahoo Japan is doing a talk on Thursday morning on their production use cases of Gimbal and Contour. And then my coworker, Alex Brand, is doing a talk on the performance testing that we've done in partnership with them. And that is also on Thursday afternoon. You'll find me there. But there are some downsides to the Ingress API. So you're only allowed to have one service per path. So heptio.com/blog can only go to one service. I can't have multiple servers to send traffic to. I can't do weight shifting. So I can't send 10% of traffic here and 80% of here. I can't do HTTP/HTTPS redirect. It's also really not safe for multi-team use. And there's some other problems. And this is a long-standing issue in the Kubernetes community. I know that it was discussed yesterday in the Contributor Summit. It's talked about in the SIG network, which is the group that oversees networking and ingress at Kubernetes. And we're trying to figure out how to best solve this. In the meantime, what we did with Heptio Contour is we created a new custom resource definition. This allows us to describe routing rules in a multi-team world. And we're able to provide some of these native extensions. The complete docs can be found in the Contour repo, but I want to quickly talk through what this YAML looks like. So the first piece is we have our API version. So it's a custom resource, contour.heptio.com/v1 beta 1 is a beta API. We are looking to roll this out to stable soon. IngressRoute is the kind, and as with all Kubernetes objects, we have to have a metadata.name. We also define the virtual host. So this is the domain or subdomain that I'm going to accept traffic for. I'm going to configure Envoy to listen for this traffic. And then I'm going to match based on a path. So in this case, I'm just using a /. So that means all requests with any path is going to be sent to the service called Heptio website on port 80. And so this means from a Kubernetes deployment perspective, if the deployment that is backing this service called Heptio website does a rolling deployment, we get a rolling deployment. We still have all the same problems that we talked about earlier for web apps, but we get rolling deployments for free through Kubernetes. We also can do blue-green deploys at this layer. So I can, instead of switching between two different services through a higher level, I can do it through the Ingress API, IngressRoute. So here I have my service called Heptio website green. If I update that to Heptio website blue, all traffic is going to immediately switch over to this other service. We also can define multiple upstreams. So if I want to have two versions of my application, I can have two different services. But it really gets interesting when we start applying weights. So we can apply a weight for Heptio website version 1 where 90% of my traffic goes to version 1, 10% goes to version 2. You can adjust those dynamically, and it's regardless of how many pods you have physically running. So it gives us much more flexibility on quickly shifting the amount of traffic between one service or another. And with Ingress, we also can do things like version routes. So if I configure my application to serve traffic on version 1 versus version 2, I configure my ingress. So any requests come to static/v1 are going to go to my app version 1. If I configure version 2, all traffic is going to go there. And there's also Ingress session affinity. So we still have to worry about the session affinity aspect. There's a couple of different ways that you can do session affinity with layer 7. The first is using cookies. So what the proxy, in this case Envoy, can do, or Nginx, is every time a request comes in, as it's going on its way back out, it injects a header. And that header is then going to be reused by the browser. And that header is going to identify which location to send that traffic to, which pod to send to on subsequent requests. Similarly, this can be done with a header. And then we also can look at the source IP hash. So depending on how your cloud load balancer is configured, if you have access to the end client IP, this is something else that we can use to shift that traffic. Now, we don't support this yet in IngressRoute. It's on the roadmap. It's something that I'm hoping that we're going to have in the first quarter of next year. If you are using the Nginx Ingress controller, they can do this through an annotation. They have a whole lot of annotations that do crazy things. But the nginx.ingress.kubernetes.io/affinity, I believe there's one option, which is cookie-based routing. Okay, so pulling it all together. So you need to choose your strategy for getting the software out. Rolling versus blue-green versus Canary. Rolling comes for free. You get that with the Kubernetes deployment object. probably a great way to roll your software out with the deployments. Blue-green is great from a web development perspective, but it does require additional compute resources. So be thinking about how much CPU and memory applications you need, how many incoming requests do you have. Maybe you can schedule that rolling deployment at times of smaller windows. You can leverage HTTP2 and or session affinity to help make sure that your end users consistently have a great web experience. It's important to make sure that you know what your cloud providers support. Read the docs, and unfortunately, sometimes you will also have to read the Kubernetes code. Sorry about that. We're trying to make that better. Versioning your static assets via CDN is a great thing. I highly encourage you to do that. And then definitely look to use Kubernetes Ingress, preferably Heptio Contour. Thank you. And I have some time for questions. I also want to point out that I'm around all week. If you want to talk about any of Heptio's open source projects, or you want to see some of the cool stuff that we are building, stop by our booth at P8 in the main exhibit hall. And we're hiring. Questions? Yes, sir.
We had a Canary deployment, and we had a discussion about what happens at the end of the deployment. During the deployment, 10% goes to Canary, 90% to the old production. And at the end, there were two options. Either Canary gets 0%, and production with the new version gets all the traffic. And second option was that split is still there. The traffic is still split into Canary and production, but both of them would have version 2 at the end. So what is the advantages, disadvantages, what's the recommendations?
It's a good question. Probably depends on how you're calculating the amount of workload you need. So this sort of gets into the talk just before me about performance testing. So if you know your production workload is scaled based on known constraints, then you want to make sure that then you don't need the Canary, right? So if you know that you need to have 10 pods running in order to handle all of your potential workload, then at some point the sum of the two needs to make sure you always count up to 10. In terms of ease of use, it's probably pretty similar. I don't think there's going to be a huge impact between those two things. Good question. Other questions? Yeah, that'd be great. Yeah.
It might be a silly question, actually.
There's no silly questions.
Okay. Say you're doing Canary, and you don't have sticky sections. So how do you control the user flow? You want the same users to get the 10% requests.
So no sticky sessions, but you want to use Canary.
Yeah.
My recommendation would be to leverage, if you can, HTTP2 will help with a lot of that. I had that in here somewhere. So HTTP2 is something your load balancer and your Ingress controller will need to be configured. But basically what happens is when the browser makes a request, it opens up an HTTP2 connection, and all requests go through that same connection. Instead of opening up 4 or 5 or 6 different connections to download assets, everything gets multiplexed through a single TCP connection. So that way you can get the good user experience while still having canaries without sticky sessions.
We just switched to Spinnaker recently, so I'm just curious about how does this differ versus doing blue-green or red-black is what called in Spinnaker, I guess.
So I haven't actually played with Spinnaker yet. It's on my holiday to play with list. If someone else in the audience knows, I believe most of the CI/CD systems are focused on just getting your software out and not necessarily worrying about shifting traffic. But maybe Spinnaker does make modifications somehow. Do you know? Does anybody know? Does Spinnaker make modifications? It does?
You can do exactly what you said with Spinnaker.
Cool. Apparently you can do exactly what I just talked about with Spinnaker. So if you're on the Spinnaker bandwagon, sweet. Any other questions? Hey, there's one over there, Nicholas, on the right.
No.
On the right.
Sorry.
Do you have any good general patterns for doing a Canary type release, but tying automation, like automated tests into that, as opposed to looking at monitoring and then having to manually roll back your release?
What is it? Flagga? Flagga, like a flagga. Oh, a flag? Apparently there's something like Flag. There's a project called Flag that maybe does that. I also know that Instana, which is a monitoring company, just made an announcement with Octopio and Yahoo Japan that they're looking on building on top of Contour and Gimbal to add, to build things like that. I don't know of any other ones off the top of my head. I think most of the time people are building their own things. Anything else? All right, well, I'll be up here if you have additional questions. Enjoy the rest of KubeCon.